So you want to generate some procedural terrain in Godot? You might want to grab a snack. Before we get into it, we really need to address the elephant in the room. How you doing today, Ed?
I got home from a conference in Toronto last night, and the only thing left in my house was a stack of divorce papers with a note on top that said, "I checked your browser history." How the fuck do you think I'm doing?
Alright, so before we get started with any of the code, we gotta get the syllabus out of the way first. If we take a look at this and you feel like you're already pretty comfortable with a lot of these concepts, you can feel free to just skip ahead to the next timestamp. If not, I do recommend that you hang out and watch through the first 5 minutes of the video or so, because we're going to discuss these things a little more in depth. So first off, what is a tilemap? A tilemap is basically a way to associate data between two different grids of coordinates. And this data can be anything, but it's most commonly rendering physics or rule-based data. Now you can manually paint tiles into a tilemap, or you can use a tilemap in procedural generation algorithms like we'll be doing in this lesson. So what's a tile set? A tile set is basically the data container that stores the information we're going to be placing into our tile map. And these two entities can exist separately, but they must be used in conjunction with one another. Without a tile set, you don't have any information to place into your tile map. And without a tile map, you have nowhere to place the information. And what is procedural generation? So procedural generation is a process by which content is generated at runtime using a combination of pseudo-randomness and a set of rules. For our use case, we'll be using pseudo-random noise in a series of algorithms to process that noise into a coherent map represented by a 2D array of binary values. Some of the algorithms we'll be using include an implementation of cellular automata as well as a flood fill algorithm. Bitmasks and binary. I'm not going to spend a lot of time talking about this. We'll discuss it a little more later in the lesson. The only thing that you really need to know is that it is required for updating the appearance of our tile map. And lastly, we come to rules and modification. One of my favorite features of tile maps is the ability to apply rules to them to modify the information that is contained in each tile. And we will be implementing some custom logic to do exactly this at runtime as well as during the initial generation process. Alright, now that we have the boring part out of the way, we're just going to navigate over to the GitHub repository that's linked into the description. And you're going to download the zip file and extract it. Once you've done that, you'll see the project file, project.godot. You're just going to go ahead and open that up and you should have something that looks like this. And I've already done a lot of the setup for this scene, as well as included some custom tooling that we're going to be using later on. So let's just get right into creating the system. The first thing you want to do is make sure that you have level.tscn open and go to the level node in the scene. And we're going to add a new script. It's going to be of type C#, and it can inherit node2d, that's fine. We'll make sure that it's empty, and we'll call it levelgenerator.cs. Okay, so now that we have our file created here, let's just start by declaring some variables. So just create a new region, call it variables. You don't have to do this, it just keeps your code looking a lot cleaner. It also allows you to just zip all this up if you don't want to look at it. So we're going to have quite a few variables in here, and we don't necessarily have to look at them all the time. So we'll just get started with a private int and call it _width for the width of our map, and default it to, let's say, 96. And another private int for the height as well. And 64 default. And we will have a private int for the border width. And we'll just default that to 3. As well as another for the density of the map. And this is going to be the percentage of 100 for which tiles will be generated as walls and which tiles will be unoccupied at the start. We'll just default that to 50. And we will have a private constant int for wall threshold. And we'll default that to 4. This controls how many of the neighboring tiles must be occupied in order for the targeted tile to also be considered occupied. We're going to use this in the smoothing method. You can try other values, but I find that 4 works the best. And we will need a private int array with 2 dimensions. We'll call that underscore map. And we'll also need a private reference to our tile map. Just call it underscore tile map, as well as a private reference to a random number generator, which we'll just call underscore pseudo random, because nothing's actually random. I think that's enough to get started. So let's just make another region here, and we'll just call this main. This is where the main loop is going to exist. And in here, we're going to have a public override void underscore ready. Now, if you're coming from Unity, this is essentially the same as your start method. And that's all we're going to need in there for now. For initialize, we'll just call it init. And in here, we'll have a private void initialize, another private void called setup, and a final private void called gather requirements. So gather requirements is going to collect all of our dependencies. Setup is going to set up all of our dependencies. And initialize will initialize everything. So in ready, we're just going to call initialize. And inside of initialize, we will first call gather requirements, and we will call setup. So it might seem weird to break it up into different methods like this, but it does make troubleshooting a lot simpler. We're going to go into another region now, and we will call this generation. And this is the region to store all of our generation logic. So the first thing we're going to need is a private void called generate map with no parameters, and a private void for update tilemap, no parameters. And we're also going to need a private bool called is border tile. And we're going to use this to check if our tile exists on the border of the map. And it's going to take in an int for the x position as well as an int for the y position. So in here, we're just going to say return, and we'll check if x is less than border width or x is greater than width minus border width minus 1, or y is less than border width, or y is greater than height minus border width minus 1. So if any of these conditions are true, it will return true. If all of these conditions are false, we will return false. Okay, so to gather requirements, that's fairly simple. All we have to do is get our tile map, and that's going to be equal to get node of type tile map in the angle brackets there. And the path is just map. And in setup, we're just going to set up the map and set that so that it's equal to a new two-dimensional array with dimensions of width, comma, height. And we're also going to set up our pseudo-random number generator. We'll just set that equal to a new random. We will be using a seed value later in the lesson, but for now, we're just going to get this working for generating some random noise. Okay, so in the generate map method, we'll just say for int x equals 0, x is less than width, and x plus plus, and the same for y, except we're going to consider the height. Okay, so the first thing we want to check is if it's a border tile. So we say if is border tile, plug in our x and y, then we will set underscore map with x and y for the index equal to 1. So when we set that to 1, we're stating that that tile will be a wall tile. And if it's not on the border, we'll actually generate some noise to fill the map with. So we'll say map xy equals pseudorandom.next, and we'll just give it 0 to 100 because remember it's a percentage of 100. And we'll say less than or equal to density. If it is, we'll set the value to 1. If it's not, we'll say it's 0. Okay, perfect. So now in the update tile map, we're just going to copy this loop because we need to do the same sort of iteration down here. So the first thing we want to check is if the map tile at these coordinates is equal to 0, we simply continue. We don't have to do anything with it. But if it's not, we're going to proceed, and we're going to actually set the cell to something from our atlas. So for the layer, we'll just use 0. For the coordinates, we'll say new vector2i, x comma y. For the source ID, we'll also set that to 0. And for the atlas coordinates, that will be a new vector2i as well. That is just 1, 0. Okay, we'll save that off. Now inside of our ready, we want to make sure that we call generate map. We want to make sure we call update tile map. Let's save that off. And now when we go back to Godot, we have a map filled with noise. Perfect. It doesn't look like much, but I promise this is exactly what we were going for. We're going to have to run this through some smoothing logic to make sense of it. So to get started on that, we'll just go back to the code. The first thing we got to do is introduce another variable. We'll just call this underscore smoothing and default it to 3. And that's going to be an int. And we're also going to want to export that so that we can modify the value in the inspector. And we're going to want a range on it as well. And we'll just say 1 to 10 for the range. You shouldn't need to run this more than 3 or 4 times. So the next thing we're going to need to do is create a private int, and we'll call this neighboring wall count. And it's going to take in an int for the x position and another int for the y position. And we're going to use this method to check how many of the neighboring tiles are considered walls. We're also going to need a private bool And we'll call this is in bounds. And that will also take in an int for the x position as well as an int for the y position. And this is a really simple check, so we'll just say return x is greater than or equal to 0, and x is less than width, and y is greater than or equal to 0, and y is less than height. So if all of these things are true, we know that the tile is in bounds. Now we can get back up into this neighboring wall count method. And we're going to start out by initializing a new variable here called count, and we'll just default that to 0. And now we're going to set up some loop. So we'll say int ny. We already used y, so we can't reuse it. And we'll say that that is equal to y plus 1. And then ny is greater than or equal to y minus 1. And ny minus minus. And we're going to do the same thing for the x. So we'll just change ny to nx and all the y's to x's. Perfect. And we'll come in here, and the first thing we're going to do is to check if the targeted tile is in bounds. So we'll say if is in bounds, and we'll use nx for the x and ny for the y. And if it is, we'll say if ny is equal to y and nx is equal to x, we will continue. And if it is not, we will say count plus equals underscore map nx and y. And if we are not in bounds, so else, we will just say count plus plus. So if the tile is on the border, on the very edge, and the neighboring tile is out of bounds, we'll just consider that tile to be a wall. Okay, so now we actually need to write a method to smooth the map. So we'll call it private void smooth map. And the first thing we need to do is create a new two-dimensional array of integers, and we'll just call it temp. And it's going to be equal to a new 2D array of integers with underscore width and underscore height as the dimensions. Now we have to do this because we can't work directly on the map set. If we try to work directly on the map array, it is going to cause some bizarre behavior. So now we need to set up a loop. So we'll say x and x equals 0. X is less than width and x plus plus, and the same for the y. Except y is less than height and y plus plus. Perfect. So the first thing we want to do in here is get the count of the neighboring walls. And we've made the method for that down here. Actually, we need to return. So we'll just say return count right here. So in here, we're going to say int nwalls for neighboring walls equals neighboring wall count at x and y. And then we're just going to use a switch statement. So we'll say temp x comma y equals nwalls switch. And we will say greater than wall threshold, lambda 1, less than wall threshold, lambda 0, and the default case will be lambda map xy. There. And finally, once we've gone through all of this, we need to set our map to the temporary array that we've set up. And the last thing we need to do is go to our generate map method. And once we've generated the map, we're going to apply this smoothing. So it's going to be an iterative process, and we can apply it as many times as we want. So let's just set up a loop for that. I is 0, I is less than smoothing, and I++. And we'll just say smooth map in here. We'll save that off. Go back into Godot, and let's press play. There we go. That's a lot cleaner. All right, so if we look a little closer at the map, we can see it's looking pretty good. But you'll notice that there are some very small regions here of just empty space. Like there's a single tile down here in the wall. This map would look a lot better if we could just eliminate these regions. For example, we'll take this small region of walls. There's only 4 wall tiles there, and fill it in with the open tiles. And the same here. We would just fill this in with wall. And to do that, we'll come back to our code, and we're going to need a list. So we'll say using system.collections.generic, and we'll come back down here. And underneath the smooth map method looks like a good place. So we'll just create a new thing here. It will be a private list of type vector2i, and we will call this get region. And it's going to take in an int for the x and an int for the y. We'll say list vector2i equals new list vector2i, and we'll just call this temp. Great. So after that, we're going to make a 2D int array. This is going to store our flags. So flags are what we're going to use to see if the tile has been checked yet or not. And this will be equal to a new int. And the dimensions on this will be the same as the rest of them. So width by height. All right, so we'll say int tile type will be equal to map x comma y. So whatever we plug in here for coordinates, it will get that tile from our grid and set the tile type to whatever value is stored in the array for that position. So if it's an empty tile, tile type will be set to 0 and 1 if it's a wall. Next thing we're going to do is create a queue. And it's going to be of type vector2i as well. And we'll just call it queue, and it's going to be equal to a new queue vector2i. And we'll say queue.enqueue and new vector2i with our coordinates x and y. Perfect. And then we'll say flags x comma y is equal to 1. Now we'll say while q.count is greater than 0. We are going to say vector2i current equals q.dequeue. And we'll say temp.add current. Then we will say for int tilex equals current x minus 1. Current dot x rather. Tile x is less than or equal to current dot x plus 1 and tile x plus plus. And the same for the y, so let's just copy this. And we'll change our x's to y's. And inside this nested loop, we're going to say if not is in bounds, tile x comma tile y, then we simply continue. And then we'll say if current dot x is not equal to tile x and current dot y is not equal to tile y, we are going to continue here as well. Now we're going to check the flags, so we'll say if flags tile x comma tile y is not equal to 0, or underscore map tile x comma tile y is not equal to tile type, we will also continue. And then we'll say flags tile x comma tile y equals 1 to denote that we have checked it. Then we will say q.enq new vector2i tile x comma tile y. And just down here at the bottom, we are going to return temp. Perfect. So essentially, this is a flood fill algorithm. So let's get started on another method here. This is going to be a private list of lists, and it is going to contain vector2i. And we will call this get regions, and it will just take an int for the tile type. And in here, we're going to make a new list of lists that contain vector2i. And we'll just call this temp as well. And we'll just say equals new this. And we will also set up our flags in here. So we need that 2D array again. And it will have the same dimensions of width and height. And we will say for int x equals 0, x is less than width, and x plus plus. And same for the y. So now we're going to check if flags xy is not equal to 0, or underscore map xy is not equal to tile type, we are simply going to continue. Next, we will set up another list vector2i. We'll call this region. And say that that is equal to get region x comma y. And we will say temp.add region. And then finally, for each vector2i coordinate, we'll just call it coord for short, in region. And we'll just go through the flags and set those all to 1. So we'll say flags coord.x coord.y equals 1. And down here, we will simply return temp again. Excellent. Now the last thing that we have to do is actually write a method to clean this up for us. So we're able to get the regions now, but we're not actually processing them and eliminating the small regions yet. So that's what this next method's going to do. And this is just going to be a private void, and we'll just call it cleanup regions. Great. So we'll have a list vector2i we'll call this wall regions, and that's going to be equal to get regions of tile type 1, and we're going to set up the same thing for the unoccupied regions as well. And we'll just call it room regions. And that's going to be equal to get regions of tile type 0. Great. So we'll say for each list containing vector2i, call it region in wall regions. So we're going to iterate through all of the regions. And we'll say if region.count is greater than or equal to min region size, we will simply continue. If it's not, we'll proceed with the logic and we'll say for each vector2i tile in region underscore map tile.x tile.y is equal to 0. So essentially what this is going to do is if the wall region is too small, it is going to set it to be a room region, an unoccupied region. And it will iterate through each tile in that region and just set them to 0. So we have to do the same thing for the inverse as well. So we can just copy this. But instead of wall regions, we're looking for room regions this time. And instead of setting them to 0, we will set them to 1. And that should do that. So let's just come up here in our generate map, and outside of our for loop for the smoothing below this, we'll just say cleanup regions. And let's give that a test. Much nicer. So you can see that we don't have any small areas left remaining here. Everything here is of a substantial enough size to declare that it is actually a region. So that's looking much better now. So just to sum up kind of where we're at so far, we've generated some noise. We've smoothed it out to make it look a little more coherent. We have identified and separated all of the different regions in the map. And we have removed any of those regions which we deem to be an insignificant size. We're a little over 200 lines deep, and it still doesn't look like a video game tile map. So in order to accomplish that, we're going to have to set up some rules that will work in conjunction with a tile set to apply the appropriate tiles where they should go on this tile map. So getting back into Godot, let's try and visualize how we're going to tackle this problem. Let's assume that the purple tile is the tile that we are looking at. That's our target tile. And it has 1, 2, 3, 4, 5, 6, 7, 8 neighbors. So what that means is that there are 2 to the power of 8 different combinations of neighboring tiles that can exist. They can either be occupied or vacant. It's a binary system. So you won't have to do this because I've already made the coordinates for the atlas. And these will follow the sprite sheet that is included with the project. But if you want to use your own custom sprite sheet where things are laid out differently, you will have to go through this process. So I'll try and explain how this works. So let's just make a new scene, a 2D scene. Just leave that as node 2D, that's fine. And we'll open up this Tilemap trainer window. If you don't see this, go to Project, Project Settings, and just make sure that the plugin's enabled. Just tick off that box there. And the first thing we want to do is decide how big our tiles are. The tiles for this project are 32 pixels, so I'll set this to 32. And then we will select our tile set asset. And then we need a file to store the coordinates in, so we'll just call it mycoords.json. Perfect. Then we're just going to hit this generate template button. And just like that, you can see all 256 different combinations. So these all have to be accounted for in order for the system to work. So you're going to want to click on the analysis tile map, and you'll see that it has your tiles in it. And just zoom in on this tile map and start painting in the way that they should fit. So this is a single purple tile. It should have the single standalone tile. And same here. You don't actually have to paint on the blue ones, but it's going to help you visualize things if you do. So you're just going to proceed through all 256 combinations and paint them in the way that they should logically be painted. And once you arrive at the bottom, you'll just hit this button that says Analyze, and it will generate the coordinates file for you. And then you'll use that coordinates file in the next part of the process. But this does speed it up substantially, having this tool available to you. As far as I know, there is a terrain system in Godot, but it does not allow you to account for all 256 possible combinations, which will have to be manually input for this system. I could eliminate 16 of the combinations for, say, this case, where there are no tiles directly beside or below or above, and just fill all these tiles in with the single tile, but it's only 16 combinations, so I didn't bother. It's just as easy to paint them in as you go. And then you got a complete set, right? You got to collect them all. Okay, so now that we have a better understanding of how this system is going to work, first thing we have to do is set up a private dictionary to store our tiles, because the system actually serializes a dictionary into that file. The key type is going to be int, and the value type is going to be vector2i. And we'll just call this underscore tiles. And the other thing that we discussed is how it's a binary system. So the best way for us to represent that binary system is going to be with a bit mask. So let's create another method down here, and it will return an int. And we'll just call it get neighbor mask. And it's going to take in an int for the x position as well as an int for the y position. So the first thing we want to do here is just create a string builder, because we're going to generate a string for the bit mask and then convert it to an integer, which can be returned. So string builder, and we'll just call it builder equals new string builder. Perfect. And next we're going to say for int ny equals y minus 1. and then ny is less than or equal to y plus 1, and then ny plus plus, and the same for the x. There's a lot of two-dimensional iteration in this lesson. And again, just replace the y's with x's. All right, now inside these for loops, we're going to check if the current tile is the same as the one that's at the input coordinates, because that isn't a neighbor. So we'll want to continue in that case. So to do that, just if ny equals y and nx equals x, we just continue. So we ignore that tile. Now we want to check if it's in bounds. So if not is in bounds, and we'll just plug in our nx and ny. Then we are going to say builder.append 1. So we're going to assume that a tile that is not in bounds is a wall. And then following that, we will just continue. And then here, we'll say builder.append whatever is at those map coordinates. And we're actually going to want nx and ny here. So nx, ny. And then outside of the for loops, we'll say string and just call it bitmask equals builder.toString. And then we will return convert.toInt32. And we will put in our bitmask. And we will say from base 2. Perfect, so that should generate a bitmask of the neighbors. Let's just throw a comment on here. Excellent. Okay, so the next thing we want to do is probably, before we get too far ahead of ourselves, is load that file into the dictionary we created. So we'll say underscore files equals tilemap helper. So load texture coords, and then it just wants the file name. So coords.json. Perfect. And now let's come up here and create another variable. And this is going to be another two-dimensional integer array. And we'll just call this underscore tile flags. And we're going to use this to store which tiles should exist at which location. So this will store the indices that correspond to that information. And down here in the setup method, we'll probably just initialize that as well. So tile flags is equal to a new 2D int array with width and height for the dimensions. Okay, perfect. Now we're going to need a method to actually generate all of these flags based on the neighbor mask that we are deriving. So let's come down here. Below the smooth map, I guess, is fine. Now let's just make another private void and call it generate flags. And inside the generate flags method, we're just going to do another loop. X equals 0, X is less than width. You can probably see where this is going. Perfect. And now we're just going to say if underscore map x comma y is equal to 0, then we say that the tile flags at that location is also equal to 0. Perfect. Else, we will say that the tile flags is equal to the neighbor mask. So tile flags x comma y equals get neighbor mask x comma y. We'll save that off. Okay, so the next thing we're going to do is come back up into our update tilemap method. We're going to change this logic. We're going to incorporate these tile flag indexes in there. So we can keep the loop, but we're going to say int flag equals underscore tile flags x comma y. And then we will say if flag is equal to 0, we simply want to continue. If underscore tiles dot contains key, and we'll pass in flag. This should actually be not contains key, and we'll just continue in that case as well. So if the key doesn't exist, we don't want to do anything. And lastly, second to lastly, we're going to say vector2i flag coord equals underscore tiles flag, and we'll say underscore tilemap dot set cell, and it is going to be layer 0 again, and new vector2i x comma y. This will be 0 as well, and then another new vector2i, and it's going to be flag coord dot x and flag coord dot y. So now we cross our fingers and press play. And it doesn't work. But I know why that is. We have to set the tile set because it's the template tile set right now. So we have to switch the tile set to the actual tile set. So now we're using these tiles instead of just the 2 base tiles. Let's try that again. That seems to be working just fine. But if we click around here, we still can't add or remove any tiles. So the next step is going to be implementing that logic. All right, so let's just jump back into Godot real quick. And we're going to set up some input. So we just go project settings and then to the input map. And the first input will be the dig. So we'll just type that in and then we'll type in place. We're going to use these to dig out parts of the terrain and replace the terrain. So just click the plus icon next to dig, and you can see it says listening for input. So we're just going to set that to left click. And we're going to do the same for place, except we're going to use right click. Perfect. And now back into the code. We're going to create a new method here. And it's going to be a private. It's going to return a list of vector2i. And we'll just call it get neighbors. And we're going to need some parameters here. So we'll just put an int for the X position as well as the Y. And in here, we're just going to create a new list of vector2i and call it temp. And we'll just set that to a new list of vector2i. And now we're going to create a loop. So for int ny equals y minus 1, and y is less than or equal to y plus 1, and ny minus, plus plus rather. And we're going to do the same for the x. So we'll just copy that and replace the y's with x's. Perfect. And now we'll come in here and we'll first check if it's in bounds. We'll say if not is in bounds, and we'll just plug in x and ny. We'll simply continue. And now we're going to set up another check. So we'll say if ny is equal to y and x is equal to x. So remember, we don't want to check the targeted cell, only the cells surrounding it. So in this case, we will also continue, so we can ignore that cell. And the next thing we're going to do is just say temp.add new vector2i with our nx and ny coordinates. And that should return all of the neighboring cells. So let's just quickly put a comment on here. There we go. Now let's just make sure we return that list. Perfect. Now we're going to stick another method down here. And this is going to be update neighbor tiles. So private void update neighbor tiles. And it's also going to take in a position. So we'll need the int x as well as the ny. And the first thing we have to do in here is collect all those neighbors. So we'll create a list containing vector2i. And we'll just call this neighbors. And we'll say that that is equal to get neighbors with our x and y coordinates. The next thing we're going to do is just a quick for each loop. And this is going to be vector2i, we'll call it neighbor. In neighbors. And for this, we are going to say if underscore map neighbor.x neighbor.y capital Y is equal to 0, we'll simply continue. We don't have to update an empty cell. So the next thing we need is vector2i. And we'll just call this flag coord. And that's going to be equal to underscore tiles. And get neighbor mask, because this is going to retrieve the index for us. And we will just say neighbor dot x and neighbor dot y. And then we say tilemap underscore tilemap dot set cell and this is going to be pretty similar to everything we've done before. So at first we need the 0. And then we're going to say new vector2i, and we're going to use our neighbor.x and our neighbor.y. And then we're going to say that it's 0. And lastly, we will create another new vector2i, and we will use flag coord.x and flag coord.y. Perfect. So the next thing we're going to need, let's just quickly put a comment on here. And we'll just say update all neighboring tiles based on input tile coords. So now we need to create some methods to place and remove tiles from the map. All right, so jumping back into the code here. The first thing we're going to need is a private list vector2i, and we'll just call this get neighbors. And it's going to take in an int for the x as well as an int for the y. Let's just quickly add a summary. We're going to use this to return all neighboring coordinates. Great, so the first thing we want to do is just create that list. We'll say list vector2i, and we'll just call it temp is equal to new with the parentheses. That's just some shorthand for the same thing we've been doing all along. And the next thing we're going to have to do is just create some loops. So we'll say for ny, capital Y, is equal to y minus 1, and y is less than or equal to y plus 1, and ny plus plus. And we're going to need the same logic for the x. So let's just copy this loop and paste that in and replace our y's with x's. Okay, perfect. And now the next thing we need is we're going to check if it's in bounds. We'll say if not is in bounds, and we'll plug in our nx and ny coordinates. And if it's not in bounds, we simply continue. Because for our purpose here, a tile that is out of bounds should not be considered a neighbor. And the next thing we want to do is say if ny is equal to y, and nx is equal to x, we want to continue in this case as well, because that is the tile that exists at the coordinates we've put in. And that means it's not a neighbor, it's the targeted tile. So the next thing is temp.add, and we're just going to add a new vector2i and plug in our nx and ny coordinates. Just like that. And then outside of our for loops, we will simply return temp. And that should do it for that method. Let's just save that off. All right, now that we have a method to collect all of our neighbors, we need a method to update their appearance. So let's just come down here. We'll say private void. We'll call this update neighbor tiles. And we'll take in an int for the x as well as an int for the y. All right, so the first thing we have to do is create a list of vector2i. And we'll just call this neighbors. And that will be equal to get neighbors with our x and y coordinates. Great. Now we need a for each loop, and we will say vector2i and we'll call it neighbor in neighbors. So we're going to loop through all of the neighbors, and we will say if underscore map neighbor.x comma neighbor.y is equal to 0, we'll simply continue. And that prevents us from checking to see if an empty tile needs to be updated. Obviously, we don't need to update an empty tile. It will always be empty. The next thing we're going to do is get our flag coord. So let's just say vector2i and call it flag coord. And that's going to be equal to underscore tiles with an index of get neighbor mask. And we will plug in our x and y coordinates here as well. So we'll say neighbor.x comma neighbor.y. Okay, next thing we need is to actually update that cell in the tilemap. So we'll say underscore tilemap dot set cell, and it's going to be 0, and then new vector2i, and that is going to be neighbor.x comma neighbor.y. And then we will have 0 again, and then another new vector2i, and that is going to take in flag coord x and flag coord y. And that should do it. All right, so the next thing that we're going to have to do is add a way to remove and place these tiles. So let's just start by removing tiles, and we'll say private void remove tile, and it's going to take in an int for the x as well as an int for the y. And the first thing we want to do in here is check if it's in bounds. We'll say if not is in bounds, and we'll pass in our x and y. We simply want to return in this instance. And the next thing that we need is a new vector2i, and we'll just call it coords, and we'll say that that's equal to a new with x and y for the coordinates. So now we have to say underscore tilemap dot erase cell, and that cell is going to be on layer 0, and the coordinates are going to be coords. The next thing we need is to update our tile flags. We'll say tile flags at the index of coords dot x comma coords dot y is equal to 0. Okay, now we'll update the map. We'll say underscore map coords dot x and y. And we'll say that that's also equal to 0. And then we'll say update neighbor tiles with our coords.x and coords.y. So essentially what we've just done is we have removed a tile from the map, and we are requesting that all of the neighboring tiles update their appearance. We're going to do something very similar for placing a tile. So let's just get started on that. All right, so let's implement the place tile logic, and that's going to be a private void. We'll call it place tile. It's going to take in an int for the x as well as an int for the y. The first thing we want to do is check the bounds again. So we'll say if not is in bounds, and we'll pass in our xy. and simply return if that's the case. The next thing we're going to do is update the map. So we'll say underscore map at the coordinates xy is equal to 1. And now we'll update the flags. So we'll say underscore tile flags at the same coordinates x comma y. It's going to be equal to get neighbor mask and xy again. And now we're going to get our flag coord. So we'll say vector2i and call it flag coord. And that's going to be equal to underscore tiles at underscore tile flags x comma y. And now we'll update that cell. So we'll say underscore tilemap dot set cell, and this is going to be 0, new vector2i with xy for the coordinates, and then 0 for the next parameter, and flag coord for the final parameter. And then after this, we are simply going to update neighbor tiles, and that will take in x and y as the coordinates. Perfect. Okay, so the last thing we have to do is go back up to the main loop region, and in here we're going to add another public override. So it'll be public override void, and it will be underscore process with a capital P. And for those of you coming from Unity, this is essentially the same as your update method, and it's going to take in a double delta. So that's going to be your like time.delta time. And in here, we're just going to call a method called gather input. And we'll come down here and create a new region and just call it input. And in here, we'll create that gather input method. So we'll just say private void gather input, and it doesn't require any parameters. So in here, the first thing we want to check is if we're trying to dig a tile. So we'll just say if input dot is action just pressed, and we'll just say dig. And if we did click the dig, we will say vector2 mouse pos for mouse position is going to be equal to underscore tilemap dot get local mouse position. And the next thing we need is vector2i, and this will be coords. It's going to be equal to underscore tilemap dot local to map, and that will take in our mouse position. And the next thing we want to do is just call that remove tile method. So we'll remove tile at coords.x and coords.y. Perfect. And now we're going to set up the placement. So we'll just say if input.isAction just pressed, and this is place. And inside of there, we'll just do the same thing essentially. It'll be vector2 mouse pos equals underscore tilemap dot get local mouse position, and vector2i coords is going to be equal to underscore tilemap dot local to map, and we will pass in the mouse position again. And then we will say place tile at coords.x, coords.y. And if we haven't made any mistakes, we should be able to go into Godot and check that this is working. All right, so if we just press play here, let's try to add a tile. Okay. Seems like we're able to add tiles just fine. Let's try removing. And we can remove tiles and the tile map updates correctly. Okay, so the last thing that we're going to do is add a few more variables. The first will be a private int called _seed, and we'll export that. And the next is going to be exported as well, and it will be a private bool called _use random seed, and we'll just default that to true. So now we're going to scroll down to our setup method, and in here we're going to say if use random seed. We're just going to do the same as we were before. Else, we're going to insert that seed in here. Perfect. If we go back into Godot and press play, we'll see that the map looks like this. Close it, press play again, and we have a different map. So let's disable the use random seed. So now we have a seed value of -420, I guess. We'll press play, and the map looks like this. And we'll try again. And we get the exact same map. So that's all working. And that's as far as we're going to take this. So if you guys found this video helpful, please don't forget to like and subscribe, share it around, let everybody know. And yeah, we'll see you on the next one.